All right, so today we are talking about simplifying radical expressions or roots and also solving with square roots. Okay, so who can remind me what we do with roots? Very good. We break them down. And then this is called a what kind of root?
Square root.
A square root. Square means 2. When you square something, it's 2. So with square roots, you need 2 for a group. So when I break down 75, it's 25 and 3. And then 25 breaks down to 5 and 5. And we're going to stop there. I have a pair of 5s and a 3 left over. I usually always circle my groups and box anything that's left over. The box stays inside my root, and then when you pull out this group, it just becomes a 5. So my answer is 5 root 3. Okay, so number 2, what does that break down to? Okay, well, we're going to go 45 and 10. Very good. And then 45 breaks down to? Good. And 9 breaks down to? 3 and 3. Once I have a group, sometimes I'll just circle it. So we have that 3 and 3. 10 breaks down to 5 and 2. So I have a group of 5s as well. And then I still have a 2 left over. So when we bring out each of those groups, you end up multiplying them together. So 3 times 5 makes 15, and then we have root 2. Okay, same thing like on number 3. Whenever you have a group, when you bring it out, you multiply it to the number that's there. So why don't you guys try this on your own? I'll give you about 30 seconds. Good. Yeah, and if you want to use whiteboards to show me answers if you want to, or I can look at some of your answers. Good. Okay, it sounds like you guys are done. So 24 breaks down to? Thank you. When I start talking, you stop talking. Thank you. 4 breaks down to 2 and 2, so I have a pair of 2s. And then 6, I can break that down to 2 and 3, but am I going to get a pair out of it? No, so if you don't even want to, you can leave that as a 6. So when I bring it out, I end up getting 14 root 6. It sounds like most of you got a chance to do 4, but if you didn't, this is how you do it. Yes, question?
I did not 8 and 3.
That's fine.
But then I got 4 and 2 and 3, and then I got 2, 2.
So you should have got 2, 2, 2, and 3, right? So you had a group of 2s. Are you okay now? Yeah, so there's more than one way of doing these problems, but you should always get the same answer, even though you're doing it a different way. Okay, so this is how I do number 4. Again, there are multiple ways of doing it, but outsides and outsides get multiplied. So what is 8 times 2? 16. Then we know we're going to have to break the square root down, right? So instead of multiplying 21 times 35, I just write it as 21 times 35 under my root, because then it's already started to be broken down. And what does 21 break down to be? 7 and 3. And what does 35 break down to be? Good. So I have a pair of 7s, but I have a leftover 3 and a leftover 5. So when I bring that out, 16 times 7, very good, 112. And leftover inside is 15. And that's your answer. Okay, do we have questions on 4? All right, moving on to number 6. Not sure what happened to 5, but we'll just pretend like we did it. All right, so on these examples, you need to rationalize the denominator. Does anyone have any idea what that means? Okay, what it means is that you cannot have any radicals, and I put or roots in the denominator. Shh. Okay. So, in order to get rid of a root 7 in the denominator, you would need another root 7 to make a group, right? So, remember though, whatever you do to the bottom, if you do the same thing to the top, so if I were to multiply by root 7 over root 7, really that reduces to what? No. This reduces to 1, right? So I'm multiplying by 1, which really isn't changing anything, except for I'm able to rationalize the denominator, get rid of the root. So remember that you're multiplying by a root 7, so this ends up making a pair of 7, so what does that become? 7. And there's no more root. Can I break down 9 or 7?
Oh, 3 and 3.
Yeah, we can break down 9 to be 3 and 3. So I have a pair of 3's, but a 7 still in the root, right? A 7 left over. So we write that as what? 3 root 7. Okay, when you have fractions, you can reduce numbers that are not in roots, and you can reduce numbers that are both in roots. So I only have 1 root on the top, so I can't reduce my roots at all, but can 3 and 7 reduce? No. So that's my answer. Do we have questions on that? Okay. Moving on. Yes? How do I get 1? You mean like making this not a fraction? You can't like not make this a fraction. Yeah, and I mean if it reduced, you could end up not having a fraction, but this one didn't reduce, so it just kind of depends on the numbers. Like if you had, this was 10 and this was 2, you could have reduced and then you had like 5 root 7. Okay? Okay, I'm not sure why we're so talkative today. So I guess we'll just waste time and wait for you guys to stop. Yeah, or just tell me. It's okay. All right. So we have root 20 over 9. When you have a root over a fraction, it means that you really have root 20 over root 9. Okay, you can always start by checking to see if you can break these down. So, can 9 break down? Very good, 3 and 3. So, do I even have a root in my denominator anymore? No, so I'm not going to have to worry about rationalizing it. Can 20 break down? Yes, what does 20 break down to? And 2. Good, so I have a pair of 2's with a 5 left over, so that becomes what? And can 2 and 3 reduce? No. So that is my answer. Questions on 7. Okay. Number 8. We'll rewrite this one. We have root 3. What's wrong? Do you need to go to the nurse? Okay. Root 3 over root 50. Okay. So if 3 and 50 could reduce, I would reduce them. But 3 and 50 can't reduce. So we just have to check if we can break these down. So what do I need to do for 50? 25 and 2. And then 25 breaks down to... So I have a pair of 5's with the 2 left over. So I'm going to write this, okay? So I still have root 3 on the top, and on the bottom, what do I have? Okay. Is it okay to have a number in the denominator? So the only thing I can't have in the denominator is what? The root 2. So what will I have to multiply to get rid of that root 2? Good. So we're going to multiply by root 2 to the top and the bottom. So now I have a pair of 2's. So what is my denominator going to become? 10. Good, because we're going to go 5 times 2, which makes 10. Can 3 or 2 break down at all? No. So we multiply those together and we have what? Root 6. Can I reduce the 6 and the 10? No. No. Very good. You can only reduce roots with roots and numbers that are not in roots. Okay? So these, one is in a root, one is not, so we cannot reduce those, and that is your answer. Okay. Now, when we are rationalizing the denominator on here, you just had a root. If you look here down in example 9, you'll notice that there is a regular number being added. Do you see that with the root? So that works a little different. You have to use something called the conjugate. Okay? So the conjugate basically is if you have a plus root b, the conjugate is a minus root b. So all you're doing is changing that sign. Everything else does the same, or stays the same. Are you with me so far? Yeah. So in order to get rid of the conjugate in the denominator here, what am I going to multiply by? All we do is change this. So it's going to be what? 3 minus root 5. Okay, now we're going to go through foiling or the box method on this, because basically we have 3 plus root 5 times 3 minus root 5. So make your box or foil, however you do that.
Wait, what is
3 minus root 5. So we have 3 plus root 5 and 3 minus root 5. So when we multiply this, we have 3 and root 5 and 3 and negative root 5. When you multiply there, 3 times 3 is 9. And then we get negative 3 root 5. 3 times negative root 5 is negative 3 root 5. 3 times root 5 is positive 3 root 5, right? And then root 5 times negative root 5 will make what? What will root 5 and root 5? That makes a pair, right? But what's a negative times a positive? So it's going to be negative 5. What do you notice about your middle terms? So I end up with 9 minus 5, which is what? 4. Okay, now we can use the box every time, but let's just look at this to see if there's a shortcut. When you're doing the conjugate, do you see a shortcut at all? Basically, this here was a difference of squares, wasn't it? Do you see that? So we square the first term, like 3 times 3 makes 9, and then root 5 and negative root 5 will make negative 5. So instead of doing the box every time, you can do it this way if you want to, because you know it's a difference of squares, but if you want to make sure you have it perfect, just multiply it out and do FOIL or box. Yes?
Is it always going to be the same outcome?
Yes, where it's like the first ones are multiplied and the last ones are multiplied. Because of the difference of squares, the middle terms will always cancel out. Okay? And then what will I have to do on the top?
The 7?
So you're going to have to distribute the 7 to this. So 7 times 3 is 21. And 7 times negative root 5 is negative 7 root 5. And do you think I can reduce 4 with any of that stuff? No. So that is my answer. Okay, questions before we move on to the next example?
Why are there so many examples?
Because we're doing like about 2 examples for each of the different types of problems. So that's why. Any questions that pertains to actual math questions? Okay. All right, I'm going to go ahead and stop this video here and we're going to start the next one.